So if your linear inequality is presented in the form shown here of x and y are on the same side together with a plus, and so you don't have the y all by itself, you cannot use the above-below method until you have solved for y. So I want to see that work, so you would subtract 6x from both sides and have 4y is greater than or equal to negative 6x minus 12. And then you would divide both sides by 4. Reducing all fractions, and get y is greater than or equal to negative 3 halves x minus 3. So now that it's in this form, then you can go ahead and say you see that you need to go above. Okay, so the next objective is to just refresh your memory about graphing lines. A lot of things in the business world do obey a linear pattern. So we're going to go back to section 2.2 and review lines. That's on page 74 in the textbook. And a line has the distinguishing characteristic that each time x goes up by 1, y increases by a constant amount. So if x goes up by 1, 1, 2, 3, 4, and y goes up by 3 each time x goes up by 1, this is going to make a linear pattern. So we're going to be plotting the points 1, negative 2, then 2, 1, 3, 4, and 4, 7. So label your axes. I am picky about that because sometimes it's not x and y. So we have the point 1, negative 2, 2, 1, 3, 4, and 4, 7. And once you have those points plotted, then you'd use a ruler or a straight edge and get it nice and straight, so then you could draw your line. And make sure you label your axes. Okay, so recall that the slope of a line, we use the letter M. And can you tell by looking at the graph we just made what the slope of the line is that we just graphed? If I start from one point on the graph and go to the next point, I go up 3 and over 1. So the slope is 3 for that graph. So remember, there's a formula for calculating the slope if you know 2 points that are on the line. So it's the second y-coordinate minus the first y-coordinate in the numerator divided by the second x-coordinate minus the first x-coordinate. So in words, that's the change in y over the change in x. You'll also see it written delta y over delta x. And then most of you have probably heard the words rise over run, which is another common way of talking about the slope. So let's find the slope of a line that connects 2 points by using this formula. So negative 6 is the x sub 1, 8 is the y sub 1, 5 is the x sub 2, and 4 is the y sub 2. So please start with m equals, again, tell me what you're going to do and then do it. It will make your work much clearer and easier to follow. So you have the second y-coordinate minus the first y-coordinate over the second x-coordinate minus the first x-coordinate. So 4 minus 8, I'm getting negative 4. 5 minus a negative 6 is 5 plus 6, so 11. So I'm getting a slope of negative 4/11. Okay, so let's talk about some forms of equations of lines. There's 3 forms for equations of lines. They're all equations of lines, and every line can be written in all 3 of the different forms. They each have different uses. If you're drawing graphs of lines, and that's a lot of what you do in algebra classes, then you probably focused on the slope-intercept form. So the y equals mx plus b is called the slope-intercept form because you can see the slope m right here multiplying the x, and you can see the y-intercept b added at the end. So if you are plotting a line using the slope-intercept form, if you have y equals negative 2/3 x plus 4, you would start at the y-intercept of 4, and then use the slope to go down 2 over 3, down 2 over 3 to make your points on your line, and then draw your graph. So remember that every point on the line makes the equation true. So if you want to do a double check of your line, you can see what this point is and plug it into your equation and make sure it makes your equation true. And then every point, every combination of x and y that makes the equation true has to be a point on the line. In fact, if you think about it, really what a line is so many points so close together that you can't see the space between them. So when we draw that line, really we are indicating that it's an infinite set of points that all make that equation true. Okay, so here's an example. Write the equation for the line with a y-intercept of 7/2 and a slope of negative 5/2. So we write y equals, the slope is negative 5/2, so I'd write the slope and then multiply that by the x, plus the y-intercept of 7/2. Then I'm going to label my x and y axes. And then I'm going to notice that my numbers are in halves. I have 5/2 and 7/2. So I'm going to use a different scale on my graph, and that's one of the things that I hope you will just attend to when you're making graphs, is think about how to make them beautiful so that they're useful for someone else. A graph's purpose is to visually convey information quickly and accurately. So I would say let each box be 1/2. So on the horizontal scale, I would mark off 1, 2, 3, 4, with each box being 1/2. So 2 boxes per unit. Then on my vertical scale, again, I would have let each box be 1/2. So then my y-intercept is 7/2. If it's helpful, you can turn that into a decimal and see, oh, that's 3.5. So I would go up to the y-intercept of 3.5 and plot my y-intercept. And then my slope is negative 5/2. So I would go down by 1, 2, 3, 4, 5, and then over 2. And here is another point that must be on my line. So I can take my ruler and then draw my line. And that's the graph of the line. Okay, so let's review the interpretation of the slope of lines, because this is going to come up a lot in our whole semester. So as x increases by 1, we're always reading the graphs from left to right, and so the x is always the one that's increasing by 1. As x increases by 1, y changes by the slope. So for this example, we would say as x increases by 1, y decreases, so the negative indicates decreasing, so you say decreases by 5/2. So you don't say decreases by negative 5/2. The word decreases indicates the negative. So you say, as x increases by 1, y decreases by 5/2. So I want to show you a very cool tool called Desmos. That's a graphing tool that you're welcome to use. You should use it to check your work, not to do your work, because it won't be helpful to you when you have to do work where you don't have Desmos available. So what I want to show you is that Desmos can help you check your work. If you want to say, what does it look like if I do y equals -5/2 x plus 7/2. So Desmos is free. It's either available on a web browser, go to Desmos, D-E-S-M-O-S, or it's a free app that you can download onto your phone, and it turns your phone into a graphing calculator. So you can check and make sure that your line looks correct, and then if you want to know what one of the points on the line is, you can touch it. Or if you say, oh, I want to check and see if the point 2, -1.5 is on the line, I can type that point in and see that, yes, it is a point on the line. So Desmos is a very cool tool, and I'll be using it a lot to illustrate things. So I wanted to show it to you early on. So if you would like to review pages 79 and 80, if you don't recall parallel and perpendicular lines, but honestly, they don't come up a lot in practical applications. So that first form we talked about was the slope-intercept form of y equals mx plus b, and I find that that's the most familiar one to most students. But the one that's the most useful for us in calculus is actually going to be the point slope form. So if you know the slope of a line and one point on it, then you can use this point slope form to write the equation of a line. And then it can always be rearranged into slope-intercept form if you do need to graph it. We are not going to be doing a lot of graphing of lines after Chapter 7. And so you'll find that when we get to calculus in chapters 11 and 12, that the point slope form is actually the most useful one. So let's look at this example where it says find the equation of the line through these 2 points, 5, 4, and -10, -2, in point slope form. Then convert the equation into slope-intercept form. So we have these 2 points, so I'm going to label x1 and y1 of the first point, and x2 and y2 of the second point. And I'm going to tell you what I'm doing. I'm finding the slope. So it's going to be y2 minus y1 over x2 minus x1. Okay, so if I just do the arithmetic, I'm going to get -6 over -15. This is never going to be acceptable as a final answer, because a negative divided by a negative is a positive, for one thing, and then you must reduce fractions. So take advantage of your calculator. If you have a TI calculator, you have a button that looks something like A and then B/C. And if you use that button to put the 6/15 in, it will reduce it for you and say that is 2/5. The Math Center is really helpful for learning how to use your calculator more efficiently, so please take advantage of them. And you can also come to my student hours or the Zoom session, and we can talk about calculator things there. Okay, so now we know the slope, but that's all we know so far. But we know a point that's on the line. So we know the slope, and we have a point. So you don't have to use the first point, but I'm going to because it doesn't have negative values. So I'm going to use 5, 4 because that looks easier to work with. So I'm going to do y minus the y coordinate of the given point, equals, then I put the m in the formula, and I found that m was 2/5, and then I'm going to have x minus the x coordinate of that given point is 5. So this is the point slope form of the equation of a line, and you're done. If you were doing a calculus problem that asks you for the equation of the line, you can stop here. If you are then asked to write it in slope-intercept form, we can do that by solving for y. We'll need to remove these parentheses by distributing the 2/5